one, we're going to identify and graph the polar equation r equals 3 plus cosine of theta. Now this is going to be a Limacon without an inner loop. I will show you the form for that in a few moments. Right now let's test for symmetry to help us graph this. And what we want to do first is test and see if it's symmetric with respect to the polar axis or the x-axis by replacing theta with negative theta. If we get back the original equation, then it's going to be symmetric. Since cosine's an even function, we can make that positive. So we do get back to the original equation. They're equivalent, so that means the test passes. Our graph is going to be symmetric to the polar axis. Now let's check for symmetry with respect to our y-axis, or the line theta equals pi divided by 2. For this, we just substitute in our theta with pi minus theta. Then we use our difference formulas for cosine and evaluate that. So this is going to equal 3 plus, let me move this down because I have this in the way. So we're going to have 3 plus cosine of pi times cosine of theta plus sine of pi times sine of theta. Now sine of theta is 0, so this is just going to be 0. Cosine of pi is negative 1. So when you multiply these two, you're going to get 3 minus cosine of theta. This does not equate to our original equation, therefore this test fails. It's not going to be symmetric to our line theta equals pi divided by 2. The last test is symmetry with respect to the pole. You just substitute r with negative r, and clearly these two equations are not equivalent, so the test fails. So we have symmetry only with respect to the polar axis, i.e. the x-axis. Now, this would be a Limacon without an inner loop. The fact that my a equals 3 and my b equals 1, because I put a 1 here, and my b, or my a, is greater than my b, 3 is greater than 1, that means it's a Limacon without an inner loop. If these two numbers were switched around, for example, if I had a 1 here and a 3 here, we would have a Limacon with an inner loop. Now this one is symmetric with respect to y, the y-axis. So it's symmetric with respect to y equals pi divided by 2, or theta equals pi divided by 2. So therefore, ours is going to be turned around a bit because ours is respected to the polar axis. All right, so let's go ahead and put some values in and assign our theta. Since it's symmetric with our polar axis, we're going from 0 to pi. And then we're going to draw the other half after we get these values. So at 0, this is 0 to pi. All right, so at 0, we're going to have 4, because that's going to be 3 plus 1. At pi divided by 6, we're going to have 3 plus square root of 3 divided by 2. That's approximately 3.9. At pi divided by 3, it's 7 halves, which equals 3 and 1/2. And at pi divided by 2, we're going to just have 3. At 2 pi divided by 3, we're going to have 5 halves. That's going to be 2.5. At 5 pi divided by 6, we're going to have 3 minus square root of 3 divided by 2, which is approximately 2.1. And at pi, we'll have 2. So let's plot the upper half of this. So at 0, we're at 4. I'm going to take that out. Didn't match up very good. So this is 1, 2, 3, 4. This is 0. I got cut off. All right. There's your first point. At pi divided by 6, we're at 3.9. So that's just a little less. All right. At pi divided by 3, we're at 3.5. 2, 3. It's half. At pi divided by 2, we're at 3. So far we have this shape. All right. At 2 pi divided by 3, we're at 2.5. It's coming down here. And at 5.6, we're at 2.1. A little coming up in here. And then at pi, we're at 2. So there we have the upper half. Now we have to get the lower half, and we just use symmetry. So at 11 pi divided by 6, we'll have 3.9. At 5 pi divided by 3, we'll have 3.5. 3.5. So it's coming around this way. At pi divided by 3 pi divided by 2, we'll have 3. 1, 2, 3. At 2 pi, 4 pi divided by 3, we'll have 2.5. Wait, let's see what's happening here. All right, my pen stopped working. 2.5 at here. 1, 2.5. And at 7 pi divided by 6, we'll have 2.1. And then we're back around. So there it is. Almost looks like a circle. Thank you. Have a nice day. Bye-bye.